CCl2H2, common sense, carbon wants 4 bonds, each of the others 1 bond, carbon in the middle, 4 groups of electrons around it, thus the carbon thinks it's tetrahedral. All 4 groups are bonding groups, so the shape is tetrahedral. So the angles, 109.5-ish. I mean, there'll be obviously some variation between them because you've got 2 different atoms bonded to the carbon, but we will just say for this level 109.5. Now, as far as assigning polarity of the molecule, this is the classic trap molecule. If you draw it like I have, you say, oh, it's nice and symmetrical, those carbon-chlorine bonds balance each other out, it's non-polar. But of course, it is not a flat molecule like this one, it is a tetrahedron. Thus, wherever you draw the chlorines, if you draw them there and there, they don't cancel each other out. Applying the little test, the third test to it, the carbon atom got polar bonds, carbon-chlorine bonds are polar bonds, no lone pair, but the carbon is attached to different things, 2 hydrogens and 2 chlorines, so therefore it is polar. Now we move into a whole series of molecules in which we violate the octeteral, AsCl5. Only possible way to draw it is with the arsenic in the middle bonded to 5 chlorines. That's 40 dots for the 40 valence electrons, so that's nice. Arsenic, obviously the central atom, 5 groups of electrons, 5 groups are trigonal bipyramidal. In this case, we see all 5 are bonds, no lone pairs, and so the shape is again trigonal bipyramidal, which looks like this. And I'll just remind you what a trigonal bipyramid is. It's where you take a trigonal planar, those nice 120 degrees, and then cap it top and bottom. Equatorial positions in that trigonal planar, axial, the top and the bottom. So the angles in this, 120 degrees associated with the original trigonal plane a bit, and then 90 degrees between the equatorial and the axial. Perfectly symmetrical molecule, arsenic, no lone pair, bonded only to chlorines, non-polar. Continuing the theme of hypervalent species, SeCl6, only way again to draw it is with the selenium in the middle of 6 chlorines. Count up the dots, there are 48, so that's good. How many groups of electrons around the selenium? 6. 6 groups of electrons arrange themselves octahedrally. We see all of those, they're all bonding groups, no lone pairs, so the shape is also octahedral, and there's the pretty little octahedron right there, okay? And the angles in octahedron, 90. This is again perfectly symmetrical molecule. The selenium has no lone pairs, is bonded all to the same type of atom, so therefore it is non-polar. ClF3, now we'll get fun. These are the interhalogen compounds, really awesome for practicing your hypervalent VESPA, because of course any molecule formed between 2 different halogen atoms, as soon as it's past 1 of each, you know it's going to violate the octeteral because they only want 1 bond each. So anyway, put the chlorine in the middle because it's less electronegative, and this would be our first guess, okay? And a lot of unwary students, unknowing students, whatever word I'm looking for, would stop right here because it looks kind of nice, doesn't it? Okay, chlorine bonded to the 3 fluorines as expected, enough lone pairs to make every atom happy. But not so fast. There's only 26 dots. We need 2 more dots. The only way you can increase the number of dots from this is to go hypervalent, and you go hypervalent on the central atom, thus the chlorine gets an extra lone pair. Now there's 28 dots. 5 groups of electrons around that chlorine, 5 groups again, trigonal bipyramid, we saw that on the previous slide. Here, however, the shape is not trigonal bipyramid because we got 3 bonding and 2 lone pairs. The way that that arranged itself is in a T-shape, which looks like this. And to refresh you on the T-shape, we are left with the 2 axial ones that are 180 degrees to each other. One of the original equatorial, but the other 2 equatorial that are 120 degrees to each other, replaced by those lone pairs. So the angles should be 90. Because we've lost all those 120 degree angles from the original trigonal bipyramid, but of course you've got 2 lone pairs pushing them away, so quite a bit less than 90 one would expect. And again, polar bonds between the chlorine and the fluorine, lone pairs on the central atom, distorting that structure, polar molecule.